Hi there. Welcome to your very first honors extension piece. This is where we take things that you've been learning in your 8th grade math class, all brand new, all exciting, fun things, and we take them just a little bit farther. For example, you finished learning about rational versus irrational numbers, number system standards 1 and 2 actually, rational and irrational numbers, and you also learned how any number that can be written in the form a over b can also be written as a terminating or repeating decimal, and vice versa. If it's a terminating or repeating decimal, it can be written in the form a over b. And the new thing you learned this year, a new 8th grade concept, is you learned that you can even do that with repeating decimals. You can take repeating decimals and turn them back into the form a over b. You guys learned a handy little trick about the nines rule, putting it over 9 instead of 10, or 99 instead of 100. And that works really, really well for a lot of repeating decimals, but not all of them. So what we're going to get into today is we're going to get into what happens if the decimal repeats after the tenths place. What if it doesn't repeat right after the decimal? What if instead of 0.7 repeating or 0.72 repeating, what if it's 0.1 and then the 5s start repeating? What if you have something in the tenths place that doesn't repeat and the repeating pattern doesn't start until the hundredths or the thousandths place? Can you still write it in the form a over b? Well, you have some notes that I uploaded the PDF. You can either print that and fill it out, or if you don't have access to a printer, that's okay. You can just format it on your own paper. But let's get to it and let's see what happens with these other repeating decimals. Okay, we are going to start by listing out the steps that help you with this over here. And as I show you the steps here, I'm going to show you how they work with a decimal that you really already know what it should be. 0.7 repeating is something that your handy little nines trick will work for, but I'm actually going to show you right now the algebraic manipulations about why it works, okay? Because there's all kinds of fancy algebra as to why this is happening. So step number 1 of your algebraic manipulation is to let x equal the original number. So the value that I'm given is 0.7 repeating. Now, why would I let x equal that? Well, because x is an unknown. X is something that we're looking for. And in this case, the really interesting thing about the algebra we're going to do here is this is both known and unknown at the moment. It is known in its decimal form. It is not known in its a over b form. And that's what we're trying to find out. So step number 1, let x equal the original number. Step number 2, we are going to now multiply by a power of 10. And sometimes you only do it once, sometimes you do it twice. But what you have to do is you have to multiply by powers of 10 in order to get the decimal both before the repeat and after the repeat. And I usually start with this one, and I'll show you why. So right now, the decimal is happening before the tenths place, which is precisely where this starts repeating. If I want that to move so that it's after the repeating place, I just need to multiply by 10. Why? Well, because that would move my decimal just one place this direction, and now my decimal would be after the repeat. Now the repeat means that these 7s continue on forever. And I put parentheses around all of this because we understand from 7th grade the way that equations work. If I multiply one part by something, I have to multiply the entire thing by 10, otherwise my equation isn't true anymore. You always want your equation to be true still. So watch what happens. This becomes 10x equals. Now, if I times by 10, I've now moved that 7 over to the ones place. And what's after the ones place? Well, a whole bunch more 7s because it's repeating, right? So now I still have 0.7 repeating here. I've just moved the decimal so that it's now after the repeat. I times everything by 10. That's all I did. Okay, step number 3 says to subtract. We'll subtract what? Well, the after repeat and the before the repeat. Let me show you what I mean. So I already have this original green statement already had the decimal in the right place. So I'm going to put that under here. And this is tricky at first. You probably won't fully understand it the very first time you watch it. It's okay, that's why we have more examples. So subtract means I'm going to take this multiplied by power of 10 and I'm going to subtract from it the original equation. And watch what happens. The reason that we do this subtraction and the reason we set it up like this in the first place for our algebraic manipulation is in this subtraction, here's what happens. This is combining like terms right here. If I have 10x minus 1x, remember that is a 1x, 10x minus 1x is now 9x. Over here, watch what happens. 7 minus 0, 0.7 repeating minus 0.7 repeating. This is a very handy manipulation here because my repeats turned 0. I did that on purpose. That's what I need to happen because it's very difficult to work with it when there's repeating decimals in it. But if I can cancel them away, now I can manage it. So 7 minus 0, 7.7 repeating minus 0.7 repeating just leaves me with 7. Now you ready for this last part? Now we solve for x. Take your brain back to 7th grade for a moment and say, oh, what's happening to the variable? They're multiplying by 9. If they're multiplying by 9, what am I going to do to get rid of that? I'm going to divide by 9, and whatever I do to one side, I'm going to do to the other side. Now this is the point where so many students grab their calculators and they type it in and they go, oh, Miss McGowan, I typed in 7 divided by 9 and I got 0.7 repeating. Well, of course you did. That was the original decimal. What we're looking for now, don't type it in your calculator, what we're looking for now is this fraction right here. Look what you just got. My pen just kept going. You just found this decimal in its A over B form. And this is the part that really you knew how to do before. This one, you were like, well, I could have just used the 9s rule on that. Yes, but this is why it works. And I'm going to show you a couple in just a second that the 9s rule would not work on. Okay, so let's try that again. There's a lot to process. Let's go through this. 0.45 repeating. Okay, step number 1 was let x equal the original number. 0.4, my pen is like really lagging. 0.45 repeating. It's good writing. Yeah, the lag is a little too much for it to handle. Okay, so let x equal the original number. Now this time, if I want the decimal to move past the repeat of this really lovely decimal I wrote, this time I don't want that decimal to only move once because that would put me right in the middle of the repeat. I need the decimal to move twice to go all the way past the repeat. So that means I am going to multiply by 100 instead of 10 this time. 100. So I always try to get the decimal after the repeat first. Get the power of 10, then we'll get it after. And then I'm going to write this down here. So that's going to make 100x this time equals. Now, if I move this decimal twice, that is going to give me 45 point, and the 45 still repeats. 45.45 repeating. Now again on this one, because the repeat started right at the 10th place, this one already had an expression for me. The original number put the repeat, or put the decimal right before the repeat. This setup right here, when you subtract, you need your repeating parts to cancel. If they don't, then you didn't multiply by the correct power of 10 somewhere, or maybe you didn't do it enough times. When you do this subtraction piece, these repeats need to cancel. That's the only way you'll get your form A over B. So watch what happens here. This time we have 100x minus 1x, which is 99x. 99x. 45.45 repeating minus 0.45 repeating leaves you with 45. Now I'm going to solve for x, this final step. Divide by 99. Divide by 99. And the last thing you need to do is simplify this. These are both divisible by 9. So I get 5/11ths. Now you can always check if you did this process correctly by now typing in your calculator, top divided by the bottom, 5 divided by 11. And look at that. 0.4545454545 repeating. Now, these are the kinds that would have worked with the 9s rule because they started repeating right after the decimal, okay? Now, watch what happens as we try one of these. Look at number 3. Notice this one, the repeat is only over the 3. It doesn't start repeating until the hundredths place. That makes this trickier, and that makes this algebraic process absolutely necessary. Because if I tried to put 53 over 99 in my calculator, 53 divided by 99 makes 0.535353. The 5 and 3 are repeating, and that's not what this is supposed to be. So let's go through our process here and let's see what happens. So if I say, okay, x equals, I'm going to do the original, but like the absolute value of the original, and I'll just worry about the negative when I'm done. So this time, okay, just the 3 repeats. So remember, you want to multiply by powers of 10 that will move you past the decimal. Okay, that's still going to be 100 on this one. So I'm going to have 100x. Now be careful here. If I move this past, I'm going to have 53, yes. But do the 5 and the 3 keep repeating? No. In this case, it's only the 3. Okay, so watch those repeats really carefully. So in this case, only the 3 repeats. Now watch what happens. Don't write this part down, but just watch. Watch what happens if this time I try to go with the original decimal. Uh-oh. Do you notice what's going to happen here? Do my repeats cancel? No, because now my decimals are not lined up correctly. This is all about lining up our decimals correctly so that that stuff cancels like we need it to. So that means I need another power of 10. I'm now going to multiply this exact same original expression. I'm going to multiply it by just 10. Because now I'm going to move that decimal 1 time. So now I'm going to have another statement that says 10x. Sometimes you have to multiply by powers of 10 twice to get your repeats to cancel. Remember, that's your goal, is make those repeats cancel. So now if I multiply by 10, I have 10x equals 5.3 repeating. Now I am ready to subtract. Now be careful here. Now I have 100x minus 10x. That equals 90x. And now my repeats cancel, but be careful right here. You're not just subtracting 0, you're doing 53 minus 5, which is 48. Now you're going to solve for x, and this super handy algebraic expression is going to get us our form a over b. Let's just simplify that. What goes into 48 and 90? 6. This calculator does have a handy button if you the fraction button. If you use that ABC 48, ABC 90, it will simplify it for you. But 6 does go into both of these. So this simplifies all the way down to 8/15. Huh, is that something you ever would have guessed? Is that something that the 9s rule would have gotten you to? No, but let's test it out. Ready? I'm going to type in my calculator. Are you ready for this? I'm going to type in 8 divided by 15. Oh, look at that. Now we have 0.5, and then only the 3s repeat. It's crazy, but that is the algebraic manipulations we use to figure out these ones that repeat after the decimal. Oh no, I forgot something. It was a negative. It was a negative decimal, so it's still a negative fraction. Okay, but you can absolutely still take these values that repeat in the hundredths, or don't start the repeats till the thousandths, or any of those places. You can still find them in the form a over b. Okay, we're gonna do one more together, and then I'm gonna let you try the last 2. All right, so let x equal the original value, 4 point. I accidentally moved the screen. I'm pushing the button. Oh, that's pretty. 4 point. You know what? I'm not even gonna write it because sometimes I don't write it. Sometimes I just go right to multiplying my values by powers of 10. So on this one, if I need to move past the repeat, the 6, it doesn't start repeating until the hundredths place. So if I'm moving past that, I still need to go 2 places. So I'm going to go 100x equals, and this will make it, and you can't see the top of those numbers there. This will make it, there we go. This will make it so that it's, I'm moving twice. Don't forget that 0, it's really important. 406.6, because only the 6 repeats. Now I'm also going to have to multiply by 10 in order to get it in front. So this multiplying by 100 got it behind the repeat, multiplying by 10 now gets it in front of the repeat, and this is the only way that my subtraction will work. So 100x minus 10x is 90x. Now my repeats cancel. You need that to happen. If your repeats do not cancel, then something went wrong. So 90x equals 366. Yeah. And then I'm going to go divide by 90. Divide by 90. Now I officially want this in the form a over b. So a mixed number is not officially in the form a over b. But even if I use this in my calculator, you can switch back and forth, and I don't care if you do that. But this simplifies all the way down to 61 over 15. Now before I put a box around that and feel good about it, I'm going to test this out. I'm going to type in my calculator, 61 divided by 15. Check it out. 4.06 repeating. And then this is the point where people always go, Ms. Miguel, my calculator says a 7, so it's not really repeating. No, your calculator is just programmed to round. Wherever it ends, it just rounds. So the next number was a 6, so it's just rounding it. All right, you guys are going to try the last two. See if you got this process down. Let the original number, let x equal the original number, multiply by your powers of 10 after the repeat, before the repeat, subtract, solve for x. Pause the video, try those last two, and then come back and see how you did. Ta-da! How'd we do? Pause it if you need to. Look over this work. You now know how to take any repeating decimal and turn it into the form a over b. A little bit of extra practice to try this and make sure you're good at it. Just a warning, at the end of this practice quiz, the one you're about to try, you will be required to take a picture and upload some of your work. So definitely make sure you're showing all this, writing this down. This is far too much to keep track of in your head. Write it down. Show me that you thoroughly understand this algebraic manipulation to help you turn a form from repeating decimal into the form a over b. And I will be checking your work and seeing how you're doing. You got this.